Hello everyone, welcome to Code with Raj. So today we would be solving our next question from our top interview 150 series. The next question is jump to. So let us come on to the question and read the question once. You are given an integer array num to are initially positioned at the array's first index when each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false. So basically what this question is saying is, let us take the first example only. So 2, 3, 1, 1. This is the array that we are given and we need to find out whether we could reach the last element or not. And we are starting at the first index. So our current index is 2. Current index is 0. 1, 2, 3, 4. So we are initially on 0. We could go up to 0 plus 2. So we could either go on 3, we could either go on 1. So if we decide to go on 3, from 3 we could jump to directly 4. If we decide to go on 1, we could only jump till 3, and from here we could also jump to 4. So like both the ways are possible. Like here both the ways are coming to be possible, but you need to find at least one path. That if one path, at least one path is there, then we could simply return true. Otherwise, we have to return false, and we are not able to jump. Let's take the second test here to see that in which case we aren't able to jump. So like here you can see if I start from index min. If I add 3 into 0, 0 plus 3 will be 3. So I will land here. And after that, I cannot move. But it's okay. So I can try to land here, here, here. So if I try to be at 2, so plus 2, again I will land here. And here plus 1, again I will land here. So in this case, it is not possible to reach at end. So how to approach this question? Basically, uh, we need to try and develop any modular approach such that we can do, because if we try to brute force this, it would take a lot of time, like a lot of time, and it is very hard to even, like, it would be hard to even code also that, because you see, from 2 we are starting, like we need to also implement recursion if we want to track all the possible outcomes. And then check if one of the possible outcomes is true or not. So it will take a very long time complexity as well as space complexity. Like if we see on 2, we can have two possible choices. Either we go on 3, either we go on 1. Then for those 2 more recursions, then for 3 again more recursions. So it would be a very bad cycle. So instead we should try to develop a greedy approach, or similar to like following some of the maths, or some of the observations. So like I want you to observe one thing. As we take our first example, like we need to know whether it is possible to reach the final index or not. We need to find a way somehow. So, like if I start from index 1, suppose I'm starting from, don't suppose, like we have to start from index 1. So, we start from index 0. 1, 2, 3, 4. So, at 0, I am placed with 2. So, what is the maximum value that I could go? Let's have a variable called max. So, I can go max up to 2. Agree? Yeah. Okay, so let me move on to the next question. So from 2, I could move on to here and here, these two blocks. So I will see whether the index of this is less than 2 or not. Because if it is greater than 2, suppose this 3. I cannot move to 3 from first index because the value 0 plus 2 is smaller than 3. So I have to move on the first and second index. So if I move on to the first, now, what is the current maximum? 1 plus 3, 4. So from here, I could move up till 4, which is greater than the max. So we update our max to be 4. Now, from here, we move on to the next position, 1. So 1 plus 2 plus 1 is 3, which is less than our max. So we won't update our max because we are already reaching further far if we are not if we are not jumping on this one. Now we move on to next position, 1. So 1 plus 3, we get to 4. So reaching the third index is also possible because our maximum value is greater than the third index. 1 plus 3 is 4. So we reached onto the fourth index. So like our maximum will become 4. Maximum is 4, and we reached onto the fourth index, so we could return true. Like I hope what I'm trying to convey is understood here. Like we always keep track of the maximum possible position which I could jump. If that maximum possible position is less than the current position where I am, then we return a false, because I cannot reach this position only. How could I reach the end? if this maximum is greater than or equal to uh, like the current position, and we reach end, then we return simply true, because our maximum value where we could reach is greater than or equal to the size of the array, so we could easily reach the end. If I iterate from the same logic in the second test case, let us do it over here. So you can see what is the maximum from here I could reach 3. We move on to the next index. So 2 plus 1, again 3, and now here 1 plus 2, again 3. Now we come here. Our maximum was 3, but we reached at index 4. So you see there is a contradiction, that how could we reach this? Like we could only reach till this index. We could not reach here. Sorry, this index is 3. This index is 3. We reached 3, then 3 plus 0 is 0. Still our max didn't got updated. And while iterating, we move on here. Now, how could you reach 4 if your maximum is only 3? You could reach only up till 3. So you cannot reach 4. Hence, in this case, you will return 4. Uh, I think if I code the solution, you would understand it better. So let us come into the code editor and try coding it. So let's have a variable n which will store the size, the array, and a max value 0. Why I initialize to 0? Because if 0 elements are there, your max will be 0 on base case. And now we will start iterating. So if our max element is less than I, we would simply return false. Because if we are not able to reach the highest position, how will we reach the max? And then we would have int position which will store the from this position what is the maximum that you can reach. So I plus nums of it. This is the maximum you can reach. And next we will take the maximum to store the maximum position further. And if this whole iteration works, means we have either reached the last position or we have crossed the last position. So in both the cases, we would return true there. So return true. Now let us try to run this one. So this got accepted on the sample list. Let us sum. So as you can see, this solution got accepted. Now let us talk about the time and space complexity of this solution. So only we are using one loop to big off and time complexity, of and time complexity, and we aren't using any extra space for big of and space complexity. This is the most optimal solution to answer if this question is asked in an interview. I hope you like my solution. Please make sure to like the video and subscribe to my channel. And please leave your feedback in the comment section. Thank you so much for watching. Bye bye.